Okay, does this work? No, not at all. Is this working? Uh-huh. Ah, there we go. Seems to be working. Good shit. Pop out chat. Hey, sorry for the slow start. Gonna continue being slow, apparently. Why are you doing this to me? Come on. All right, there we go. Now we'll need this tonight, but you know. Right. Where were we? We weren't anywhere. Oh yeah. We got this quiz. Advanced traits. Okay, what is on with my audio? That is really trash audio. What's going on there? What are we using for the microphone? Hello. That's not what. How about now? No, that's not helping. What is capturing this? Default. That's. Oh, it's over here, right? Oh, that's doubling up. Well, that's really kind of you. How about now? Right, that's gonna have to work. I stopped Karen. Right. Okay, so advanced traits, it's starting to come back to me. Starting to come back to me. Okay, yeah, right. This is gonna be a really slow day, ain't it? Hair looks trash. I'm sorry about that. I am a sick man. A sickly boy? Alright. Advanced traits. Recall the definition of the add trait. We have a trait, add, RHS equals self. Yep. So type is output. Hmm. I can't fully remember exactly what this is. It's been a week, but I'm going to just try and track along. Maybe I'll remember, maybe I won't. I don't really care right now, but you know. Which of the following best describes why output is an associated type? Well, RHS is a type parameter. Response. An associated type cannot have a default, while a trait type parameter can have a default. I don't know. I don't know about that. The add operation takes RHS as an input and produces output as output. It doesn't produce output. And type parameters are used for input, while assign types are used for output. I don't even know what that's saying, man. A trait can only have a single associated type. RHS must be a type parameter to add. And type T should be addable to many other types S. But a given T plus S operation should always have a single output type. Huh. I think that might be it. Type T should always be addable to many other types S, but given type T plus S, I don't actually, no, that doesn't sound right. Nope, don't think that's right. Right, so this is essentially saying when you try and add two things together, and the right-hand side, the thing you're trying to add to it also equals self, the type is self, or the type is whatever original type you bring in. You output something from self colon output. So an associated type cannot have a default, while a trait type parameter can have default. There's no defaults in here. Maybe that's it. Output is an associated type. The associated type cannot have a default. That doesn't necessarily mean that output needs to be that. The add operation takes right-hand side as an input and produces output as an output, and the type parameters are used for input, while associate types are used for output. That actually, now that I reread it, makes the most sense. A trait can only have a single associated type, so right-hand type must be a type parameter to add. That doesn't describe why output is necessarily a type. Kinda does. Ah, fuck it. There we go. Recall the definition of the add trait, which the following best describes why right-hand side is a type parameter to the trait add, rather than the function add. That is, why is add not designed like this? So that you can add the add trait, or you can utilize the add trait on anything. Code generation for the add function would require additional time for monomorphization due to the function level type parameter. I'll admit I can't remember what monomorphization is. The type checker executes more efficiently when right-hand side is a type trait level type parameter than a function level type parameter. Wouldn't that be? No, that wouldn't be. That wouldn't be the same thing. Okay. Right-hand side cannot have a default type as a function level type parameter. I don't see why it wouldn't be able to. If right-hand side were a function level type parameter, then the definition of add could not assume any structure to right-hand side. I think that's it. But who knows? It could be on monomorphization. Right. Determine whether the program will pass the compiler. If it passes, write the expected output if it were executed. So we got a module called inner. We got a public trait A. As a function, f of self is that ever used? Enter PB. Right. P.f. All right, what are we using? P.f. Implementing B for P. I don't think we're actually utilizing A at all here, honestly. Taking in P, and we're taking in B, implementing B. All right, so we got function F taking in a reference to itself, and now putting a U size 1. I think this is obviously going to put out a 1, right? Implementing A for P. Yeah, this is what's A for P, which is a trait. Holding a function F, which outputs this U size. This will override it. This will shadow component. I don't see why compile this. The only reason for it not to is just shitty code. Maybe it'll stop you from that, sure. Consider implementing a trait for a type T in which the following situations. You each wrap T in a new type times the external trait. If it's the same external trait, it doesn't matter. But consider implementing a trait for type T. Yeah, you need new types on both, wouldn't you? Trait is defined in the local crate, and T is defined in the local crate. Nope, that is fine. Trait is defined in the local crate, and T is defined in an external crate. That's implementing type trait T for T. Yeah, that's fine. That's chill. That's good. What? Is that different? Trait is defined in an external crate, and T is defined in a local crate. Trait is defined in the local crate, and T is. Oh, I'm wrong on that one. Yeah, you can't implement a trait on that T if it's from an external crate. I think that's correct. We got 2 out of 4. And the last one we got wrong. How? Uh, what? The correct answer is trait is defined in external crate, and T is defined in external crate. Okay, so as long as everything, one of the things is local, you can do it fine. Whatever. Sure. I got this right. It does compile and out this one. When only 1 or 2 conflicting trait implementations is important, then Rust uses the imported implementations. Fully qualified syntax is not necessary here. That's what it's trying to remind us. Remember that if we have to alternate traits, it'll bug out if we try and just utilize it, unless you just specifically import one. But if we did import both P and uh, both B and A separately, we would have to fully qualified syntax to state exactly what piece we want on that. Alright, we got this correct. If RHS were a functional type parameter, then the definition of array did not assume any structure to RHS. Such a design would not make much sense because the right-hand side would not have any information about the structure of the right-hand side. So it would be impossible to implement any sensible addition function this way. Firstly, okay. Yeah, because you can overwrite this, can't you? RHS can be anything but output necessitate the self. I think that's what it's saying. Uh, Probably never going to see this advanced trait thing. So let's go on to advanced types. This is a rather sharp one. This is probably all I'm doing today. Advanced types. The Rust type system has some features that we've so far mentioned but haven't yet discussed. We'll start by discussing new types in general as we examine why new types are useful as types. Then we'll move on to the type aliases, a feature similar to new type with slightly different semantics. We'll also discuss the exclamation mark type and dynamically sized types, using the new type pattern for type safety abstraction. This section assumes you've read the other sections using the new type pattern to implement external. The new type pattern is also useful for tests beyond those we discussed so far, including statically enforcing that values are never confused by indicating the units of a value. We saw an example of using new types to indicate units in listing 1915. Recall that millimeters and meter structs wrapped 32 values in a new type. If we wrote a function with a parameter of type millimeters, we couldn't compile a program that accidentally tried to call that function with a value of 3 meters or 32. We can also use the new type pattern to abstract away some implementation details of a type. A new type can expose a public API that is different from the API of the private inner type. New types can also hide internal implementations. For example, we provide a people type to wrap a hash map I-32 string that stores a person's ID associated with their name. Code using people would only interact with the public API we provide, such as a method to add a name string to the people collection. That code we need to know when we assign an I-32 ID to names internally. The new type pattern is a lightweight way to achieve encapsulation to hide implementation details. which we discussed in the encapsulation that ties implement details section of chapter 17. Right. Creating type synonyms with type aliases. Yeah, that's fairly useful. Plus provides the ability to declare a type alias to give an existing type another name. First, we use the type keywords. For example, we can create the alias kilometers to I-32 like so. And then we implement stuff on kilometers, which is not structured strictly implemented on I-32. I would assume this is an assumption, not a statement of fact. Sorry. Now, the alias kilometers is a synonym for I-32, like millimeters and meters types we created in listing 1915. Kilometers is not a separate new type. Values that have the type kilometers will be treated the same as values of type I-32. We have an I-32, let x equal I-32 5, let y equal kilometers 5, then we can just add them all together. Because kilometers and I-32 are the same type, we can add values to both types, and we can pass kilometer values to functions that take I-32 parameters. However, using this keyword, we don't get the type checking benefits that we get for the new type pattern discussed earlier. In other words, if we mix up before this is a messy block. It's type alias makes this code more manageable, right? By reducing repetition 1925, we've introduced an alias named thunk for most type and can replace all the bases of the type with a short alias thunk. Here we go. Let me just say let answer type thunk equal a new box. Good stuff. This code is much easier to read and write. Choosing a mutable name for a type alias can help communicate your intent as well. Is a word for code to be evaluated at a later time. Okay, whatever. I've never heard that before. So it's an appropriate name for the closure that gets stored. Now that's a broad name. That's a fairly broad name. You could have a different alias for what bug does in fact directly mean any code that is used to be evaluated later, and perhaps we should be on with them. Remember, yeah, they did tell us about things earlier on. About the name. Aliases are also commonly used with the result T type for reducing repetition. Consider the standard IO module in the standard library. IO operations often return a result of type T and with an error. Sorry, to handle situations when operations fail to work. This library has a standard IO error step that represents all possible IO errors. Many of the functions in standard IO will be returning result of a type of an error, where the E is standard IO errors, such as these functions return in the tree. Yeah, error. I'm assuming error is one of these aliases. The result of anything error is repeatable, and as such, standard IO has a type alias declaration. Yeah. Type result of any type. This. Okay, so we can just have result of any type. It's It's a lot easier. I like it. How long have I been muted? Is this shit not working? What's going on here? There's something going on here. It ain't working, man. Right, how long we got on the way? Best, I don't know. Oh, fuck off. Right, I'm just done today. This is a failure. Alright. Seems to be still fucked up. I can fix this soon. I think I'm just gonna end it because this is okay.